All right, Math 2, we've got our first lesson in Unit 3. This is called Congruent Figures. Make sure to put your name and period up here. The question is, why does order matter in a congruent statement? And we're going to find out what a congruent statement is later, and obviously order matters. Okay, so our first definition, I'm just going to put all my definitions over here in blue. So my definition is just the definition of what congruence is. Now, congruence is the congruent sign. So it's like an equal sign with a little squiggly on top. All right, so that means that there is equal measurement. So it's the same size, but the objects may occupy different spaces. Now, in equations, we usually don't have to worry about the congruent sign. We just use the equal sign. But in geometry, we actually need a new sign because equal is not good enough. In geometry, equal means exactly the same, meaning it's taking up the same space. So if I've got a triangle over here and a triangle over here, and they're the exact same size, I can't say they're equal because they're in two different spaces. So I need to say that they're congruent instead. And congruent means their measurements are the same, but they may be occupying two different spaces. So that's what congruent means. All right, and now when we're doing shapes, the definition of congruent shapes is two things. Number one, all the sides are congruent. And not only are the sides congruent, all the angles are congruent. Okay, so let's just really quickly draw a couple of triangles over here. Let's see, I'll just make one like this because that makes me happy. So there's one triangle over here. How am I going to make this other one? I'll just make it like boom, boom, boom. All right, so I got two triangles over here. Let's call this one A, B, and C, and this one over here is going to be D, E, and F. All right, so in order for those two triangles to be congruent, we would need to show that all the sides are congruent. So let's pretend that AC over here is the same length as DE over here. Now, the tick mark is what is showing that this one is congruent to that one. Okay, so not only does that side have to be the same, maybe AB has to be congruent to DE. So that's two sides the same, but all the sides have to be the same. So then I'd have to say BC, and notice I'm using one more tick mark each time just so I can tell which side is congruent to the other side. Got words all of a sudden. All right, so let's say that that happened. And let's say this angle up here is 60 degrees. And then I'm going to say angle D is also 60 degrees. So those two angles are exactly the same. And then let's say this one is, I don't know, I'm just making up stuff here. Let's make this one 40 degrees. And let's say that F matches that one. And then what am I left with? 80 degrees. So I'm going to say that this one is 80. And this is 80. Now this is the definition of a congruent shape because all three sides are matching up and all three angles are matching up. We can now say that those two shapes are congruent shapes. They're not equal to each other because they are occupying two different spaces, but they are congruent to each other. All right, corresponding parts. Corresponding parts are the sides or angles that are congruent to each other. Now they're congruent to each other in the congruent shape. So looking at this example up here, I notice for my sides, AC, so remember when you write a segment, it has to have the segment line over there. AC is congruent to DE because they both have one tick mark. So that would make them corresponding parts because they're congruent to each other. And then AB has two tick marks on it. Oops. And then over here, DF has two tick marks. So those are corresponding parts because they match up with each other in the two congruent shapes. And our last side, of course, is BC is congruent to EF. So those are the three pairs of corresponding parts for the sides. And then we have three angles that match each other. The 60-degree angle, angle A. So angle A is congruent to angle D. And those are corresponding parts because they match up in the congruent shape. Angle B is 40. Say angle B is congruent to angle F, which is 40. And then finally, I'm going to write that angle C, which is the 80-degree angle, goes with angle E in the other triangle. So those are all of our corresponding parts. So we should have, in triangles, we should always have 6 pairs of corresponding parts, 3 sides, 3 angles. If it was a quadrilateral, you know, a polynomial with 4 sides, then you'd have 4 sides and 4 angles that would have to be corresponding parts. So every single side has to match with another side that are corresponding, and then every single angle has to do the same. Now, congruent statement is how we write out the two triangles, and it has to be very specific. So a congruent statement lists the corresponding parts of the shapes in order. They must be in the correct order when you do a congruent statement. Now, what I would suggest when you do a congruent statement is pick one of your triangles, and then you can do it in any order you want for the first triangle. So I'm going to just say, okay, A, B, C. All right, so my congruent statement will say triangle A, B, C, because I picked that order, is going to be congruent, because it's a congruent statement, see? So it's going to be congruent to triangle. All right, now the order really matters. Since I picked A first, A was the 60-degree angle. So since I started with A, I have to start with D on the other one. So I'm going to write D. My second letter that I picked was B. That's the 40-degree angle. And then it would have to go with the F1, because that's the 40-degree angle. So my second letter has to be F. I cannot do this in any order that I want. I have to do it in a specific order. They have to be in where the corresponding parts are matching up. C is my last one. That was 80 degrees, and that matches with E. So the congruent statement is ABC is congruent to DEF. Now look, we did it with the angles, but look what happens to the sides. AB had 2 tick marks, right? AB, and that's the first and second letter. Now look over here, DF. DF has 2 tick marks. So now the sides are in order. BC had 3 tick marks. Now look at the last 2 letters over here, FE. FE, oh, they've got 3 tick marks as well. So everything is matching up. The first and the last AC had 1 tick mark. The first and last here, DE, has 1 tick mark. So I suggest that you set it up by putting the angles in the correct order first, and then the sides automatically become in the correct order, where all the corresponding parts are matching up now. All right, so example 1. We've got 2 quadrilaterals, So that's a four-sided object. One of them is ABCD, and they say that it's congruent to XSTV. Now we're going to assume that this is a congruent statement where everything is in the correct order. So without seeing a picture of this, I now know that BC, second and third letter, has to be the same size as ST. Because we got the second and third letter, so that's the one side of the quadrilateral, it has to match up with the second and third from the second one. So that's what's nice about congruent statements, is when you have them already written out, then you know exactly what is congruent to what without drawing the picture. So over here I've got angle V. Angle V is the last letter over here, so that one must correspond to angle D. And now I know that those are congruent without ever seeing a picture, because I have a congruent statement. Lastly, if angle B equals 70, so angle B is the second one, then what would we know? Well, we should know that angle S should also equal 70. So the measurement of angle S has to also equal 70. Because remember, congruence means the measurements are the same. So if this angle measures 70 degrees, and this is a congruent statement where the second letters are both angles, then this angle S also has to equal 70. All right, we're almost done. Next part, something called the third angles theorem. All right, so we've already talked about the triangle sum theorem. The triangle sum theorem says that the three interior angles of a triangle have to add up to 180 degrees. Well, here's what the third angle says. The third angle theorem says if two angles are already congruent, so if two angles of a pair of triangles are congruent, then the third angles are congruent. Okay, so here's what that's saying. I've got two angles here, they're congruent. I got two angles here, and they're congruent over here, right? So A and F are the same, B and D are the same. This says that if that happens, I don't need to know the third angle. I don't need to. Automatically, the third angles have to be congruent to each other. So I should know at this point that angle C has to be congruent to angle E. The third angles are congruent. Now, why is that? Well, let's put some numbers in here. Let's say that this one was 85 degrees. Okay, so that has an angle tick mark, so that means this is 85 degrees. Let's say, I don't know, that looks like 45-ish. I'm going to say 45 degrees for that one. Now, the reason why the third angles theorem works is because all triangles have to have their interior angles add up to 180. So right here, these two add up to 130, which means that this has to be 50 degrees. Well, if these two add up to 130, this one also has to be 50 degrees. And now the third angles are congruent. I don't even need to know what these two angles are. The third angles are always going to be congruent if the first two angles are congruent. So we're going to use that in some of the things that we do. All right, now we're going to get to what's called a proof. And this is a two-column proof. If you were in Math 1 last year, you probably did paragraph proofs where you just kind of talk through the logic of what you're doing. This is a very specific type of a proof where one side you make a statement and the other side you have to give the reason. Now, what are the reasons? The reasons are all these blue things that I've been writing down. These are reasons that we're going to use. And the stuff from Unit 1, like the alternate interior angles, vertical angles, stuff like that, that's also going to be a reason that you're going to use. So you're going to need to remember that terminology because that's going to be part of your reasons over here. All right, so a two-column proof will always have a couple sections to it. Number one, it'll tell you what information you already know. That's called the given. Number two, it'll tell you what you're trying to prove in the end of this. Right now, we need to prove that these two triangles here are congruent to each other. Third thing it's going to give you is some kind of diagram that you can refer to. All right, and then you're going to prove what you need to know. Now, right now, to prove that two triangles are congruent, we have to show that all the sides are congruent and all the angles are congruent. So that means 6 things need to be proven congruent. Let's see what we have. I've got AB is congruent to BC. Let me make a mark there. AB is congruent to BC. All right, so far I've got one side congruent. Then they say that angle C is congruent to angle A. So this is angle A and this is angle C. And they're telling me that that one is congruent. So now I've got one side and one angle. All right, here they tell me that angle D is congruent to, or side AD is congruent to side DC. So let's see, AD's right here and DC's right here. So now I have another side. Lastly, I've got angle ADB. ADB, that's this angle right here. I'm going to mark it twice so that I don't confuse it with this angle. And then CDB, CDB, that would be this angle right there. So those are congruent. Okay, so the first thing that you do is you write your given down, because you have to have a starting point somewhere, and the given's our starting point. And then the reason why I was allowed to write this down, I always have to give a reason. In this case, it's because they gave it to me. So I'm just going to write the word given. I know this is true because they gave it to me. Now, we do not have enough information to prove that these two triangles are congruent, because all we have is 2 sides and 2 angles. In order to prove that we have congruent shapes, we have to have 3 sides and 3 angles proven. So my job at this point is I've got to prove that this angle and this angle are the same, and that this side from this triangle is the same as this side from that triangle. Let's start with the angle. We already know what that's going to be because we just did the third angles theorem. The third angles theorem states that if 2 angles are the same in 2 triangles, then the third angles have to be congruent. So now I can say, okay, this angle and this angle have to be congruent to each other. That would be angle ABD has to be congruent to angle CBD. Why do I know that? Because these 2 angles are congruent, which makes the third angles congruent. That's called the third angles theorem. So that's what I write over here. It's one of our rules for math, and we can use it. So your reason section has to be a rule for math. All right, so let's look at my data so far. I've got 3 angles. That's all the angles I need, but I only have 2 sides. So I need to prove that BD from, let me change colors so it can look pretty. I'm going to say, no, that's too much like the other. Oh, I think this, yeah, this is a good one. All right, I need to say that BD on this side is the same thing as BD on that side. Well, that's pretty obvious, right? BD, I didn't pick a good color. This one looks too much like green. So BD from this triangle, so this side from this triangle, is equal to BD from that triangle. It's almost too obvious that it seems like we shouldn't have to write it, but we do. Now, the reason for that is something called the reflexive property. You should have covered that last year, but if you didn't, here's your reminder. The reflexive property says anything can be congruent to itself. So BD and BD are the same thing, so they have to be congruent to itself. We now have our third side. We've got 3 sides proven congruent, and we only prove it when we show the congruent sign. So 3 sides have been proven congruent. 3 angles have been proven congruent. That is what we were talking about with the definition of congruent shapes. All the sides are congruent, all the angles are congruent. So now, as my last step, I can write that triangle ADB, so what I was trying to prove, I can now write it, is congruent to triangle CDB because of the definition of congruent shapes. The definition of congruent shapes says that if all the sides and all the angles are congruent, then the shapes are congruent. Well, I just proved that all the sides and all the angles are congruent. So now I can say that the 2 triangles are congruent. And that is a 2-column proof. It's lovely. We'll practice those a lot. So if you're not quite getting it yet, don't worry. We got more along the way. All right, that's all I got for you today. Sorry this one lasted a little bit longer, but that's how it goes. All right, see you later. Bye-bye.